Hello, welcome today. We're going to look at the higher degree polynomial equations. So this is x cubes, x to the fourth, x to the fifth, some general strategy for solving these by factoring. A lot of these aren't solvable by factoring, so we're going to look at special cases here. Later on in the semester, we'll look at things that don't solve easily or they're not obviously factorable to solve. But today we're looking at this. We're going to use the methods of: is there a greatest common factor we can take out of all terms? What are the special forms? And finally, we're going to factor by grouping. Okay, so special forms. There's a difference. Squares. A squared minus b squared equals a minus b times a plus b. And then there's also a sum of cubes, which is a cubed minus b cubed plus b cubed is a plus b times a squared minus ab plus b squared. And then there's a difference of cubes. And difference of cubes is essentially the same as difference of sum of cubes. So a cubed minus b cubed equals a minus b, a squared minus plus ab plus b squared. When you look at this, you get ab, a squared, ab plus b squared. So the way it's going to work is, if we start with a plus, then the first parentheses is a plus, and the next line is going to be opposite. Minus, minus, opposite. And the b squared here will always be positive. Okay, let us do some examples. So solve x squared plus 21x minus 100 equals 0. I'm sorry, that's not right. That's too easy. This should be x to the fourth plus 21x squared minus 100. Now, as you saw in the other video, the previous video, this is quadratic in form, right? You have constant, a square, and the final one is double your middle term. So the 4, right, is double the 2. So when we can factor this, just we're going to do it in terms of x squares instead of x's. So now I'm looking for the factors of 100 to add to 21. So the factors of 100 to add to 21 would be 4 and 25. It's a minus 100. To get plus 21, I need a minus 4 and a plus 25. So x to the fourth plus 25x squared minus 4x squared minus 100 equals 0. Now the first two I can take out, x squared. X squared, this needs to be x squared plus 25 minus, take out minus 4 on both cases, x squared plus 25 equals 0. X squared minus 4 times x squared plus 25 equals 0. Now, right, sum of squares, just a reminder, is unfactorable over integers. So we're not going to factor that anything nice. We could factor, but we're not going to. This here, x squared minus 4, that's x squared minus 2 squared, so that's going to be a difference of squares. We have x plus 2, x minus 2. We're not going to factor the sum of squares. So everybody equals 0. I have x plus 2 equals 0, x minus 2 equals 0, x squared plus 25 equals 0. So x is minus 2, x is positive 2. This one, if I get the x squared by itself, I can just square root it. So subtract 25, subtract 25, x squared equals minus 25. To get rid of a square, we're going to square root. So square root x squared equals square root of minus 25. Remember, whenever you take the square root of both sides, you got to put a plus or minus right there. So x equals plus or minus. The square root of 25 is 5. Right? The square root of minus comes out as an I. This is my solution, or if you want to do a solution set, minus 2, positive 2, plus 5i, minus 5i. So that's a solution set of it. All right, let's try another one. All right, 27x cubed plus 64 equals 0. So we have two terms. So if I have two terms, either it's going to be a greatest common factor, or it's going to be a difference of squares, not sum of squares because we don't factor those, sum of cubes or difference of cubes. Does 27 and 64 share a common factor? 27 is made up of 3's. 64 is made up of 2's, 4's, or 8's, depending on how you factor it. But let's note, 27 is actually 3 cubed. So this is 3x everyone cubed plus 64. If you look at it, you may say 8 times 8 at your first look, which is fine. But what do you know about 8? 8 is 4 times 2. And the other 8 will be, we'll call it 2 times 4. This right here is another 4. So how many 4s do you have? 1, 2, 3, 4 cubed. So that is a sum of cubes. And so recall, that's a plus b, a squared minus ab plus b squared. So to be clear, this in here is a, and the 4 is b. So we're going to have 3x plus 4. It's plus, right? It's plus the first place. In the original problems, we have plus in the first parentheses. This can be a squared, so 3x squared minus, right, plus minus 3x times 4 plus 4 squared equals 0. So 9x squared plus 12 minus 12x plus 16 equals 0. And the thing to keep in mind here is, can I factor anymore? Mm-mm. In general, this thing here will always be unfactorable. Let's go right to the up top. Too far. These two things right here are unfactorable. That doesn't mean we can't solve them, it just means we can't solve it by factoring. So since it's unfactorable, I'm going to say each of these pieces equal to 0. So we'll do the simpler one first. So 3x equals minus 4. X equals minus 4 thirds. 9x squared minus 12x plus 16 equals 0. Not factorable. You can check if you want. Or we could say, let's look at the quadratic formula, right? X equals minus b plus or minus the square root b squared minus 4ac all over 2a. So x equals a is 9, b is minus 12, and c is 16. So minus a minus 12 plus or minus square root minus 12 squared minus 4 times a, which is 9, c, which is 16, all over 2 times a. So positive 12 plus or minus square root 144 minus, well, 16 times 4 is 64. Then 64 by 9. Multiplication here real quick. 9 times 4 is 36. Put 6 down, carried in 3. 9 times 6 is 63. Okay, so apparently I can't multiply. 9, crap. 9 times 4 is 54, not 60. So this is 576 all over 18. Well, 576 minus 144, 2, 3, minus 432 over 18. Since the minus inside, go ahead and put the I out here. 432, what do I know about that? Not very much. So we're gonna do some scrap work here. So we can figure out. I know, if I look at the last two digits, if 4 divides evenly into the last two digits, I know 4 goes into the whole thing evenly. So I know that 4 goes into 32, so this is gonna be 4, this is gonna be 4 times. With a little calculator work, you'll get 108. 108 is 4 times 27. So that's going to be 4 squared times 9 times 3. So that's how it's going to break down. So 4 squared times 3 squared times 3. All the squares are going to come out nicely. So x equals 12 plus or minus. Square root of 4 squared is going to be 4. Square root of 3 squared is going to be 3. The I is still outside, and this 3 here stays in. Over 18. All right, now in order to simplify it, I need to factor the numerator. There's a 12 here, right? We have a 12 here and here. So I can factor that out to the front, leaving me with x equals 12, 1 plus or minus square root of 3 over 18. Twelve and 18 share 6, so 6 goes into 12, 2, 1 plus or minus I square root 3, and 6 goes into 18 3 times. And there's our simplified answer. So it's a little bit involved, but it's doable. All right, let's do another one of these. We're going to solve 5x cubed plus 6x squared minus 20x equals 24. All right. So pretty much when you're solving, I haven't mentioned this, but almost always make sure this is a 0. So in our case, we're going to have to subtract 24 from both sides. So I have 5x cubed plus 6x squared minus 20x minus 24 equals 0. All right, so is there greatest common factor? For example, does every term share x? First term has x, second term has x, third term has x, nothing in the fourth term. So no x is not common across all 4 terms. Do the coefficients of the constants share? 5, 6, 20, and 24? Well, 6, 20, and 24 all share 2's. But 5 does not, so I can't do that, so that left with the grouping. So let's see, what can I take out both the first 2 terms? Well, there's an x cubed and x squared, so we're going to take out x squared. There's a 5x plus 6. The last 2 terms, so the 2 minuses here, we'll take out a minus, and 20 and 24 share values of 4. So it'll be 5x plus 6 equals 0. Or x squared minus 4 times 5x plus 6 equals 0. X squared minus 4, this is x squared minus 2 squared, so it's a difference of squares. So x plus 2, x minus 2, 5x plus 6 equals 0. Everybody's factors, we're going to set it equal to 0 now. X plus 2 equals 0, x minus 2 equals 0, 5x plus 6 equals 0. So x equals minus 2, x equals plus 2, and this was a little more work. 5x equals minus 6, x is minus 6 over 5. So our answer, or if you like a solution set, minus 2 minus 6 over 5 plus 2. That's our solution set. Okay. The last thing I'll talk about is solving polynomial-like equations. An example would be solve x to 7 halves minus 5x to 5 halves plus 6x to 3 halves equals 0. Okay. We call this polynomial. Well, it's not a polynomial because a polynomial has to have, to be a polynomial, these all have to be whole numbers, and they have to be positive. These are fractions, so, but it can behave like a polynomial. So what you want to do is you want to find the smallest variable with the smallest power. And that happens to be this. This is the smallest. So that means, since this is the smallest power on x, that means x to 3 halves is a common factor of x to 5 halves and x to the 7 halves. Now you remember how this works, right? When you multiply powers, or x's powers, you are adding them up, right? So let's look at this. If I have x to 7 halves, can I rewrite the 7 as addition, right? Can I say this is 4 plus 3 over 2? X to 4 plus 3 over 2? Or what that really means, this is x to the 4 halves times x to the 3 halves. Or x squared times x to the 3 halves. So x squared, x to the 3 halves, minus 5. Let's look at x to the 5th. If I rewrite that to be what adds 3 plus what adds to 5, I do 2 plus 3 over 2, x to the 2 over 2, plus x to the 3 halves, or x to the 1 times x to the 3 halves. So this is x to the 1 times x to the 3 halves plus 6x to the 3 halves. And now you can see x to the 3 halves is your common factor. So take that out, gives you x squared minus 5x plus 6 equals 0. Factors of plus 6 that add to minus 5, well, that's going to be 2 and 3. x minus 3, x minus 2 equals 0. Completely factored, set everybody equal to 0. Now, the x to the 3 halves to the 0 power, you could do a little more with it and be more precise, but the only way that x to the 3 halves equals 0 is if x is 0. Or if you want to do interval notation, set notation, solution set, 0 to 3. All right. Let me know if you guys have any more questions.